Hey guys, it's Nivi, and this is my black hole lab. So the objective of this lab was to estimate the mass of a black hole by analyzing the motion of a star. The star's data was given to me on a CSV file, and I used Python in order to analyze its computational model and figure out the mass of the black hole. And my result was that the mass of a black hole is 3.5822 times 10 to the 31 kilograms. The principles we used for this lab was the momentum principle, which states that a change in momentum equals the net force acting on the object times the change in time. And for this case, we use the derivative form of that, as you can see here. Newton's law of universal gravitation states that there is a force of attraction between all masses in the universe, and its formula is negative g, the constant, times the product of two masses divided by the distance between the objects squared times the unit vector. Now, we were given a little bit of background information before coding for the computation model. We received the star's mass, the change in time, and the black hole's position. And I inputted that information right here. Next, we were asked to find the y velocity of the star as the star moved around the black hole, and I did that like this. So after knowing the initial velocity, I was able to find the initial momentum formula by multiplying the initial velocity by the star's mass, and I did the same to find the final momentum formula, but in that case I used the final velocity. Then I calculated the change in both velocity and momentum. The momentum principle states that F net equals the change in momentum divided by the change in time. I first calculated dp dt parallel by first finding the direction of momentum, p hat, and then finding the magnitude of dp dt. By knowing that dp dt magnitude equals the magnitude of change in momentum divided by delta t. I multiplied the two in order to get my dp dt parallel. So we know that F net parallel plus F net perpendicular gives you F net. So we can switch the equation around to get F net perpendicular, which would equal F net minus F net parallel. So we basically did that over here, but with dp over dt, which is equivalent to F net, and in this case dp over dt perpendicular is equivalent to F net perpendicular, as shown here. So to find the black hole's mass, I had to make an equation in Python, and I basically rearranged the f-graph formula. And so f-graph's magnitude times the distance between the two objects, squared divided by the gravitational constant times the mass of the star. And basically I rearranged that and I got that equation. So this is what happens when I run the program. The yellow is the F net, the blue is the F net perpendicular, and the black is the F net parallel. And my mass for the black hole is given right here, 3.5822 times 10 to the 31st kilograms. So now we're talking about what does it mean. In my analysis, I need to differentiate F net perpendicular, F net parallel, and F net by the change in the momentum divided by change in time. Perpendicular, parallel, and just regular. So we know that F net equals F net parallel plus F net perpendicular, and F net parallel equals dp parallel over dp or over dt, and F net perpendicular equals dp perpendicular over dt. But the difference is in first, well, the net force affects the star's motion, while dp over dt doesn't. dp over dt only shows how the star is moving. And F net can be calculated just by simply doing the F-graph formula, but dp over dt needs more calculations that I showed right here and I talked about. So the what if question states that imagine the black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion of the observed star remains the same and is affected only by the gravitational force of the new black hole. Could I tell the difference? No, I can't tell the difference because if the motion of the star is unchanged and the data points in the star data file are the same, then there is no alternative gravitational force to calculate. My g is going to be the same, my mass for the star is going to be the same, the change in position would be the same, and the unit vector as well. So I can't tell the difference. Anyways, thank you for watching, and bye.